Hello everyone, I am Dr.P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Today I am going to discuss about the construction and working of Ruby laser. At the end of this lecture, the students will able to understand the construction of Ruby laser and they will learn the working of Ruby laser. Coming to the schematic representation of the Ruby laser is given here. In this one, there is a ruby rod. Actually, this ruby belongs to GEMS category. It is a solid state laser. The ruby is taken in the form of a cylindrical rod of 4 centimeters long and 1 centimeter the cross sectional area. See the opposite ends, this is one end, this is another end. The opposite ends are maintained in such a way that one end is 100% reflecting, this is 100% reflecting end and this is partially reflecting end. The remaining surfaces are maintained roughly to prevent the emission of light through them. Anyhow, these two will constitute the optical resonator or a Fabry-Perot resonator arrangement. Here, the ruby rod, it is surrounded by helical xenon flash lamp. This is the xenon flash lamp which produces white light in the form of sparks. See, coming to the construction of this one, once again, ruby actually belongs to GEMS category. Ruby belongs to GEMS category. It is actually aluminum trioxide, but some of the aluminum ions are replaced by chromium ions with a percentage of 0.05% in weight. Actually, aluminum trioxide is transparent. It is a transparent material. Because of the chromium percentage, it gets color. As the chromium percentage increases, the color also increases from pink to red. Here in the ruby rod, we are taking the aluminum trioxide, but some of the aluminum ions, Al3 plus ions, they are replaced by chromium ions, Cr3 plus ions with a percentage of 0.05% in weight. And coming to the rod is taken in the form of 4 centimeters long and 1 centimeter square cross sectional area. It is surrounded by xenon flash lamp, and we have seen here the opposite ends. The opposite ends are maintained in such a way that one is 100% reflecting, second one is partially reflecting end. They are constituting the optical resonator or Fabry-Perot resonator. It is also called as optical resonant cavity. And say in this one, cooling arrangement is also provided. Say observing this one, this is surrounded by one case and cooling arrangement is also provided. If at all some thermal energy is produced, so water circulation is allowed, means the water is circulating around this one. Cooling in and cooling out means water is in, water out. Water circulates around this one. As a result, if at all thermal energy is generated during the process of laser action, so that will be cooled here. Okay, one by one we shall see here. So, coming to the construction, already basically ruby belongs to GEMS category, in which actually aluminum trioxide, some of the aluminum ions are replaced by chromium ions with a percentage of 0.05% in weight, and the dimensions of the rod is also taken as 4 centimeters long, 1 centimeter cross sectional area, and to provide the input energy we are taking the xenon flash lamp. It is producing the energy in the form of white light, in the form of tube light sparks, and optical resonator arrangement is there, cooling arrangement is also there. Coming to the working of the ruby laser, so we have to concentrate here the basic principles or basic requirements. What is the pumping method, what is the pumping scheme, and what is say the optical resonator, where the optical resonator arrangement is there, how the laser action is taking place, what is the output of the ruby laser, that what we have to see. Coming to the pumping method, in case of pumping we are using the optical pumping method. Generally, in case of optical pumping, if there are two energy levels, say, so the photon energy h nu is absorbed by atoms or ions, so that the ions will go to the excited state or higher energy state. And after some time, the population of the ground state, suppose it is N1, population of the excited state is N2, N2 will be greater than N1, means there exists a population inversion after some time. Here we are applying the photon energy. Photon energy is absorbed by the ions. When just you observe this energy band diagram, initially one point, actually in the ruby material, aluminum ions are there, chromium ions are there, oxygen O2 minus ions are also there. Actually O2 minus oxygen ions are inert and aluminum ions are a little bit massive. Chromium ions are the active centers. So the active medium in this one is the chromium. So coming to the energy band diagram in this one, initially the chromium ions, these chromium ions are lying in the ground state. They absorb the energy from the xenon flash lamp. So if you observe the pumping input, that means light, photon energy is absorbed by the chromium ions, they will go to the higher energy states. Actually this belongs to a 3-level pumping scheme. In case of 3-level pumping scheme, there exist 3 energy levels. What are those 3 energy levels? Ground state is denoted by E1, excited state is denoted by E3, in between these two there is another energy state E2 called metastable state. As usual, initially the ions or atoms lie in the ground state, they absorb the photon energy and they will go to the excited state. Afterwards, some transitions must be possible. What are those transitions? From E3 to E1 or E3 to E2. Already we know in case of 3-level pumping scheme, E3 to E2 transition is forbidden. Anyhow, the ions will come to the metastable state E2. They stay for some time and after some time what happens? There exists a population inversion, say N2 of the energy state E2 will be more than the N1, the ground state. Automatically there is a population inversion. Wherever there is a population inversion, laser action starts. What is meant by laser action? Out of all the atoms or ions in the excited state, initially one ion comes to the ground state emitting a spontaneous photon. This will stimulate an atom in the excited state, therefore that comes to ground state emitting 2 photons. They will stimulate 2 more atoms in the excited state or iron state, so that they come to ground state, 4 photons will be released. Again they will stimulate 4 more ions, 8 photons, next 16, 32, multiplication effect takes place. In that way, from E1 and E2 states, there exists the laser action. You observe here, this is the energy band diagram of the ruby laser. This belongs to a 3-level pumping scheme. This is the ground state denoted by E1. The higher energy state, actually some of the chromium ions will go to the lower energy states, some of them go to higher state, but total is taken as one energy band. Means some chromium ions have the absorption range in the green color, some of them are having the absorption band in the visible blue color. Anyhow, all the ions are going to the higher energy state. Later on, some transitions should be possible. Means here this is the metastable state E2. Most of the ions are coming to the metastable state. From E2 and E1 state, there exists population inversion and laser action takes place. Just now as we discussed here, laser action takes place, and between E1 and E2 states, laser light will be emitted with the wavelength 6943 angstroms or 694.3 nanometers. This is in the visible red color light. Actually, the chromium ions are absorbing the blue color and green color, they are emitting the red color light. So, in this way, we get a monochromatic and means continuous red color light, laser light we get between E1 and E2 states. Once again, just observing this one, say this is the schematic representation for the ruby laser. Basically, ruby, it is taken in the form of a solid material. Ruby belongs to gems category, gem material, it is a gemstone. Of course, it is basically aluminum trioxide, but some of the aluminum ions are replaced by chromium with a percentage of 0.05% in weight. Because of chromium only, the material is getting the color from pink to red. And anyhow, here to provide the energy, we are taking the xenon flash lamp, or this is producing the light in the form of white light in the form of sparks, just like tube light. And of course, these photons are absorbed by the material. Actually, out of aluminum and chromium and oxygen, only the chromium ions are the active centers, active medium. Active medium means wherever there is a population inversion, that is called active medium. Here only the chromium ions absorb the xenon flash lamp energy, so that they will go to the higher energy states. Later, different transitions are possible between E1 and E2 states. Laser action takes place. Actually, here we have discussed one point. This is 100% reflecting surface. This is the partially reflecting end. Remaining surfaces are maintained roughly to prevent the emission of light through them. That means this is constituting the optical resonator or Fabry-Perot resonator arrangement. Actually, initially 1 photon is generated, next 2 photons, 4 photons, 8, 16, something like that. If they strike the partially reflecting surface, they will be reflected back. While passing in the reverse direction, again they will stimulate more and more number of photons. Finally, they will reach 100% reflecting surface. Again, they will be reflected back. In that way, light travels to and fro in the medium, and until it gets the amplified, and at the resonance condition, it comes out of the partially reflecting end as a powerful and unidirectional monochromatic beam. In that way, we get finally the wavelength of the light 6943 angstroms, visible red color light. So this is the construction and working of ruby laser. By using the ruby laser, we can get monochromatic and single colored, highly intensified, highly directional laser beam with a wavelength of 6943 angstroms. So at the end, means from this article, the students can understand, means what we have discussed is ruby laser construction. What is the construction of the ruby laser? How it is working? What is the output? Basically, we have to concentrate here what is the pumping method, pumping scheme, and what is the optical resonator arrangement, what is the output of the laser. All these things everybody should concentrate. So that's why we have discussed here the construction and working of the ruby laser in this one. Thank you very much.